Okay, I'm going to talk about ideal gas laws. And I'm going to derive the ideal gas law constant for you. So I'll start with the ideal gas law. Got ahead of myself. PV equals nRT. Okay, so let's derive the ideal gas law constant. R. Okay. A few things we have to know. We always have to know standard pressure. So you should always know STP conditions that pressure equals 1 atm. Temperature equals 273 Kelvin. You should know that your molar volume is at 22.4 liters, is equivalent to 1 mole. So what I'll do is I'll solve for R. And R is our ideal gas law constant. So mathematically, PV equals nRT. I'm going to isolate on R, divide both sides by N and T. Okay, and then R is equal to PV over NT. Well, if I was to look at pressure being 1 atm, I'm going to plug in 1 atm. Volume is 22.4 liters at that pressure. And at that volume, there's 1 mole of gas. And the temperature is 273. Okay, and I'm very aware of my units. Atmospheres times liters over moles times Kelvin. Okay, and then there's my R. All I really have to do is take 22.4 and divide it by 273, and it's 0.0821. And the units, ATM per liter per mole per K. Okay, and that's times. Now you can have 3 different R's which depend on your pressure. So this is pressure equal 1 atm as a standard. So this is for atmospheres. And if you're doing a problem, depending upon what your unit of pressure is, you pick different R's. If pressure is equal to 760 millimeters Hg, or torr, I take that same equation and I say R equals P times V over N, PV over NT. And I plug in all my variables. Now pressure is 760 millimeters of mercury times 22.4 liters over 1 mole times 273 K. Mathematically, I take 760 multiplied by 22.4 divided by 273. Your R is equal to 62.4. And now your units are millimeters of mercury times liters over moles times K. Or I could say, for those units, torr per liter per mole per K. And then finally, if I was to say my pressure equals, let's take 101.3 kPa. These 3 pressures are all standard pressure. So we get to use 3 different pressures, so we end up with 3 different R's. That's your second R right there. Same thing. R equals P times V over NT. I change 760 to 101.3 kPa times 22.4 liters over 1 mole times 273. Now mathematically, I would take 101.3 times 22.4 divided by 273 and find out that my R, when I'm using kilopascals, is equal to 8.134 kPa per liter per mole per K. And that is the ideal gas law constant at 3 different pressures. Temperature can never be anything but 273, and it has to be in K, and at 22.4. Now from here on in, once I know my R's, all these variables can change. Okay, R doesn't change. I just found it at one condition to set that up for you. Okay.